Afternoon all. Now this is an update to my review on the 2 and 3 cell mobile power banks, because in the original review I was perhaps a little overcritical of the 2 cell power bank because I said that it had a low output voltage. It was about 4 volts. So let's put this back to where I was when I said that and see what happens. So when I criticised this thing for having a low output voltage, and you can see that at the moment it's 3.75, it was 3.99 when I did this last time, it was pointed out to me by a couple of commenters that I had the charger lead in and that I should perhaps take it out. So let's do that. Let's take the charger lead out and see what the result of that is. Wait for it to go back to volts. Well, that's interesting. No improvement. In fact, it's dipped down even further now because the batteries aren't being charged. Now, unfortunately, I've got my very poor quality, fake, I suppose, batteries in here, so it's not as good as the previous time when I had a couple of quite nice batteries in there, these two, as it happens. Now, if you're sitting there screaming at me saying, well, you need to switch it on, you idiot. Okay, I'll do that. Switch it on. Get the incrementing and decrementing sequence. And with 3 LEDs charged. What's the voltage? That's it. Fixed. So when you plug the charger cable in, it turns off the boost converter, and what you see on the output is just the battery voltage. When you take out the charger cable, it doesn't turn the boost converter back on, it leaves it switched off. When you then press the, what you might call the on switch, the mobile power bank goes back into its normal mode with the boost converter on and a proper voltage on the output. Now, this was pointed out to me in the comments after I uploaded the video. Henny193 said, does the voltage get higher when you remove the charger on the 2 cell one? And I said, yes, it does. Well, actually, no, it doesn't. It does when you press the on switch, but not when you immediately after you remove the charger. And I should say a special thanks to Nico Duck, who went to some lengths to explain to me what I'd done wrong about leaving the charger cable in, and also actually about why my Nexus 7 wasn't charging properly and why it was saying charging USB and not charging AC, and it all has to do with 2 different short length USB to mini cables, but I'll come back to that in another video. So just for a moment, let's compare what happens when you remove the charger cable from the 2 cell power bank with what happens when you remove it from the 3 cell power bank. So as I showed you before, remove it from the 2 cell power bank and the voltage stays low, so the boost converter doesn't spontaneously spring back into action. But compare that with the 3 cell power bank. So on this one I've got 5.34 volts. I'm going to start charging it. Little set of lights comes on and the voltage does the same as the 2 cell power bank. It ducks down to 3.98, 4 volts. The batteries in here are a better type. Now when this goes back to voltage, I'm going to pull out the charger cable. So pull out the charger cable, it briefly goes off and then immediately restarts the boost converter and is giving me 5 volts again. That's sensible. This is a bit silly. So what about this notion that after charging this particular power bank, you need to switch it on? Well, what's on and what's off? I mean, it goes through that sequence, shows me the power level, that then will turn off. And although that restarts the boost converter in this, how is this any more on than when it was off? In fact, what do on and off mean? They don't really mean anything. This thing exists in 2 states. One where the boost converter is off immediately after putting the charger lead in and taking it out. And the other state is with the boost converter turned on, and that only happens when you go through this power checking sequence. So it's not really on and off. It's just boost converter running and boost converter not running. It's still a bit strange. And if you just weren't knowledgeable about the circuitry inside here, had this thing on charge, took the charger cable out, but didn't think to press the button, this thing would then only put out 4 volts. And although that charged my Nexus 7, it didn't charge my Nexus 4, and you'd have problems with it, and you'd be saying this is no good. So yes, you need to remember to press that button, but it's an oddity. And that got me thinking, I wonder what the response is on all my power banks, and this is all 6 of the ones that I currently have, to having the charger lead plugged in and the charger lead taken out. And the result was very interesting. I will present it in a different video, but basically all 6 are slightly different in their response to those 2 events. Very, very weird. So now that I've worked out how to get this thing to produce a 5-volt output, I need to go through the current tests again to check this 1.5 amp claim. And rather than the resistor blocks, I'm going to use something much more sophisticated this time. A big 5 ohm rheostat. So at 5 ohms, which should draw 1 amp, we're drawing a little bit less than an amp, 0.87 amps, but the voltage is holding up reasonably well. It does seem to be bobbing around a little bit. Let's start loading this thing up by reducing the resistance. So that should be about 1.5 amps, but the voltage is dipping 4. It's difficult to see, I need to shade it. 1.05 amps. Now if I go to the halfway point, that should be 2 amps. And this thing doesn't seem to be able to sustain that. Oh, the voltage is dipping away quite badly now. And I'm nowhere near 2 amps. 1.3 amps. I'm getting very low resistance here. I'm certainly getting 1. Oh, now the voltage has dropped way down. This isn't going to work, is it? Because the batteries that are in there are those poor quality ones. Let's put some decent batteries in and see what this thing can generate. Now that means, of course, that I've got to remove this lid, and this is not going to be pretty. No, it wasn't pretty. But anyway, let's get these cells out and get some decent cells put in there. In fact, let's put those eFest cells in, those really high current ones. So here are the eFest lithium manganese cells. Let's just do a battery check. Silly sequence. Fully charged. Good. Let's see what current we can get out of this thing. So 0.8 amps at 5 ohms. Let's start bringing that down. 1.08, 1.2. But the voltage is dropping away. Let's go for halfway. 0.3 amps. I can feel the rheostat warming up. Yeah, the voltage is ducking down a bit now. Let's see if I can get this 1.5 amps. Yes, 1.5 amps. Less than 2.5 ohms. That's about 2 ohms. But now, of course, the voltage has ducked away quite badly to 4 volts. Well, 4 volts was okay on the Nexus 7, and I am getting 1.5 amps. So maybe this... Oh, the voltage is really struggling a bit. I think I want to back this off a bit. Oh, the rheostat's getting quite hot on this side. It's not really able to provide 1.5 amps at 5 volts. But it kind of makes a reasonable attempt at it. 1.3 amps at 4.6 volts is about what it's capable of. And something over this side of the circuit is very, very hot. I suspect it's the inductor actually, which is sitting underneath this part of the circuit. That is burn your fingers off hot. But it didn't die, it survived, so it's not a bad power bank. I've certainly, it's gone up in my estimation. I think it is, for the money, actually quite reasonable. But don't forget that after you've charged it and removed the charging lead, you have to press the button and do a power check. Otherwise the boost converter isn't switched back on again and you won't get 5 volts out of it.